Well, here we go again. Welcome to Module 6, Lesson 3, Solving for Unknown Angles Using Equations. Okay, just another extension of what we've been doing. So moving from Lesson 2 now to Lesson 3, pretty much doing the same. We're going to be solving for unknown angles in word problems and in diagrams involving all learned angle facts, things that we've learned about angles and their relevant relationships. Okay, so let's just get it done. Here we go. Opening exercise. Two lines meet at the common vertex of two rays. Two lines meet at the common vertex of two rays. Okay, so can you tell which are the lines here? Okay, again, really important thing to do. And you can see the only two things going straight are these here. And that would be line, we have line AB and line CD, okay? And then these here are our rays. And that would be O or EO and FO or OE and OF, whatever. Okay? All right, so now we know the measurement of angle AOF. That's this right here. Boom, 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 is 134 degrees. That's what we know. So what you're going to do right now, and you're going to do it on your own, set up and solve an equation to find the value of x and y. Okay? Are your answers reasonable? And how do you know? Okay? So go ahead and do that in the opening exercise and come on back and compare it to what I have done. Okay, so again, like we found out last lesson, there are many. There are often going to be many different ways to do problems. Okay, to solve them. So, if you did it differently and you still got the same answer, just be very proud of yourself. Because if you remember last lesson, I did it, and the way I had originally done it, or completed it, or set it up, proved to be a lot less efficient. Though it was fun, less efficient than it could have been, okay? But the way I'm going to approach this, excuse me, is I am going to approach this as angles on a line. I'm going to go from that perspective, okay? I think anyway. All right. So what I do know is that we have these right here, all of this right here is 134 degrees. Actually, this is really quite easy, isn't it? And then this is just a line. Okay, so these are all angles on a line. Again, these are not supplementary angles, okay, because they're supplementary angles are, remember, two angles that equal up to 180, but angles on a line are also going to equal up to 180. Therefore, if all of that is 134, that means I would just have to add, I would take 180, subtract away 134, and I would get, what, 46, right? And the way that would look here would probably be, and again, 46 for y, okay? So I've solved for y here, okay? So y would have equaled, if I set it up as an equation, would be, well, it could be 180 minus 134. Okay, could do it that way. And there we go. And then I'd end up with that y equals 46. Okay. All right, so if I know that, I know that fact, let's just go ahead and put that right in there. We know that, let's clean this all up here. Okay, we know that y is 46 degrees right here. Okay. So we have y equals 46, because it's the first thing we needed to do, or, well, whatever. So now we got to look at x, okay? So here is our x right here, okay? Here is our x. All right. So, again, simple or not simple? Well, yeah, could be quite simple, because what we know here, and if we set up an equation, we can say that x equals, and again here is our line right here again, okay? And those angles on a line include this one here, this, as well as that minus that, okay? I don't know if you can see that because this 134 includes that 14 as well, okay? So let's just see what that looks like. So I could say x equals 180 minus 46 and minus 14 and minus 134 minus 14. Okay? I did 134 minus 14 because I just want to take this away here because I don't want to include that twice. Okay. All right, so let's go ahead and do that. So if we have 180, I just add up all these minuses. What is that? Negative 46, that's negative 60. And then this is 120, negative 60. So that is, oh, this can't be right. I think I better stop and look at this. I was about to come up to x equals 0. Yeah, and that's not right. Well, let me look at it. Well, something I totally did not see, and again, you guys know by now I don't see very well, but something I missed in here was our little right angle symbol. So this angle right here, this EOF right here, is actually 90 degrees. Therefore, I know this here is 90. Okay, this here is 14. This is my only unknown, and I know the whole shooting match equals 134. Therefore, what do I need to do? I just need to do 14 plus x plus 90 equals 134. Okay? All right, and you know what to do here. I have this is 104, these two together. So I subtract 104 from here, and I get 30. And then I get x equals 30. Okay, so x equals 30 degrees. Okay, and hopefully you got that. And maybe you did it more efficiently than me without missing that very important little right angle symbol, which is there as well. Okay, so let's go ahead, erase this, just put this up here so remember that, 30 degrees. Okay, so let's see, example 1, very simple, cut to the chase, set up and solve an equation to find the value of x. Go for it, and come on back. So, I'm wondering how many of you were confused out there. Maybe you weren't, maybe you were, okay? But yeah, let's talk about this. I mean, it didn't set anything up for us. It didn't say, you know, a ray is comes off of the vertex of a 90-degree angle. Okay, they didn't give us anything, didn't talk about it at all. They just threw that at us. But hopefully you noticed something, because this right here, we could actually make a circle out of this, a little pie. And if we make a circle out of that, truth is we could have made a circle out of this as well. Okay, before, and the one down here. Okay, we'll get to that one now, that exercise 1. Therefore, the the relevant relationships here are that all of these angles, these 3 angles, are going to equal up to 360 degrees. Therefore, we know this is 90. This is already, we know, is 123. Those together are 213. Okay, so I guess as an equation. So it should be x plus 90 plus 123 equals 360. And then x equals, this is equal to 213, subtract 213, x equals 147 degrees. Okay, 147 degrees. Now, you can check this with a protractor. Okay, I think this is supposed to be to scale here. But we can also see that it makes pretty good sense, because if we looked at it and just take all, let me just erase this here, and if we just made another, like just a straight line there is 90 degrees, that would make sense. Here's 90 degrees. This is not completely 90 degrees, but it would be like about 57 degree angle here. Okay, it's more than half of 90. Okay, so yeah, that makes sense. So x would equal 147. And I wonder who got it out there. I hope many of you did. Okay, here we go. So exercise 1 gives us a little more detail. 5 rays meet at a common vertex. A common vertex, real important. In a complete sentence, here we go again. Describe the relative relationship in the diagram and set up and solve an equation to find the value of A. There it is, A right there. Okay, so yeah, set it up and solve and come on back. Okay, as we had mentioned before, this is also the I guess the relative relationship would be the sum of angles. Remember angles at a point? We haven't talked about that in a while. Angles at a point equal 360 degrees. Okay, so that is our statement of relative angle relationship. Okay, and again, it was the sum of angles at a point. We had angles on a line and angles on a point at a point. We haven't actually seen that till right now, these last two. Okay, so again, this is, and again, angles at a point, what it just assumes is that you can make this into a circle. Just like we had mentioned before, okay, you could make that into a circle, and they're all going to equal 360. All right, so let's go ahead and set up an equation. Okay, well, hopefully you were successful. This one's a little teeny bit tricky, because if you notice, we have we have two right angles that are formed here. We have this one here, and then we have this one here. And the issue is that there is this 21 degrees that kind of overlaps. Okay, so you can't actually add it twice. Okay, so we're going to have to get rid of the thing. Okay, we're going to have to get rid of it because it is actually extra, because we have added this. We have this 190 here. You have this 190. If I added another, not 190, this 90, and then if I added another 90 like that, that wouldn't be correct, because that's not a line, first of all, but it includes this overlapping 21. Okay, so we have to get rid of that. All right. So we'll set up our equation like this. So we have 90 plus 90 minus 21. Okay, so that takes care of that overlap, and plus A, which we were solving for, plus 143, which we know, all has to equal 360. And that's real simple. Solve for this here. What is this? This is 69. So 90 plus 69 plus 143. What are those together? That is 159 and 143. What is that? 302. So 302. So of course we're going to subtract all that away. We're going to subtract it from here. 302. And that means A equals, it's an A, not a 9, but A equals 58. Okay, so A equals 58 degrees. Right? That's right there, 58 degrees. Okay, next is example 2. 4 rays meet at a common vertex. In a complete sentence, describe, again, the relevant angle relationships and then set up and solve an equation to find the value of x. Okay, so we're trying to find x right there. Okay. Also, they want us to find the measurements of these two angles, BAC. Well, hold on a second. Is that right? BAC. Well, that's the value of x, isn't it? That's weird. And then DAE. Okay, so we're finding that and that. If we find the value of x, I think we've already found the value of BAC. So, anywho, maybe that was a trick question. Anyway, go ahead and see what you can do with this, huh? And come on back, pay attention to this and any kind of overlapping mess you may need to deal with. Okay? Okay, let's take a look at this one. I guess it wasn't as hard as I thought it might be. It wasn't really that mucky. So we have 204, okay, and that takes up that whole entire angle there, okay. And we can add 5x, which is part of our unknown. 90 degrees is revealed to us by the box in the corner, and then x right there all equals 360 because this is an angles at a point relationship, and angles at a point equal up to 360 degrees. Okay, and here we go. So we just combine like terms, subtract away that coefficient there, and we end up with x equals 11. Okay, so we have the answer to our x. We have our answer to this one right here. Okay, that's 11 degrees. But now we need to figure out that one. And all we need to do is multiply 5 times our x value, which is 11, and we get 55 degrees. Okay, so if we add all of those up, if we add 11 plus 90 plus 55 plus 204, we end up with 360. Okay, all right, here we go. Next one, 4 rays meet at a common vertex. You know the drill here. Pretty much the same thing. Relevant relationships. Set up and solve an equation to find x. Right. Well, yeah, I guess we're just getting x. And then we're going to find the measurement of CAD, which is this right there. Okay. All right, go ahead and good luck. Okay, we're back, and let's see how you did. Okay, so first let's just deal with this relevant angle relationship, and we know these are angles at a point again that equal 360. Okay, so we know that is 90 right there because of our box. Okay, right in the corner. We have 60 is given to us. And then we have these two unknowns. We have 12x and we have 3x. And all of that, of course, because we are talking about angles at a point, all of that is going to equal 360 degrees. Okay, let's get rid of all that. Give myself some room here. Okay, just rewrite all this. Equals 360 on one line. Okay, so we know the drill. Combine like terms. Okay, and then subtract away that 150 from both sides. End up with that. Go ahead and multiply both by the multiplicative inverse, or divide by 15. And I get x equals 14. Okay, so that's our first part of our problem. And we also want to know the measurement of angle CAD. And to do that, we just need to multiply by 3 times 14, because it's 3x, and we get 42 degrees. Okay, all right, let's keep plugging along here. Okay, here's example 3. We have two lines meet at the common vertex of two rays. In a complete sentence, well, just the relevant angle relationships, set up and solve an equation to find the value of x, find the measurements of angles BAC and BAH. Okay, so we're going to find those two angle measurements and then find the value of x as well. So go ahead. I'm sure there are many different ways to do this. I have one particular way I'm going to use. You use whatever way suits you. Okay, so come on back when you're done. Okay, so here we go. First step, I just went ahead and plugged in that 90. That's 90 degrees, thanks to my little box. I also understand that these are numbers on a line here. Okay, numbers on a line, angles on a line. Therefore, that has to be 60 degrees to make that entire relationship 180. So I guess I've used angles on a line to figure that out. Okay. There's another relationship. I'll just write these down. So I used the relevant relationships I used angles on a line. Okay. Number 2 relationship. If you look here, what did I use there? I used vertical angles. Okay, so I used the vertical angle relationship. Okay, vertical angles, and now I can start my solution. Okay, so let's go ahead and do that. Let me erase this though, because I'm going to be working over there. Okay. All right, so I have 90 plus 30 plus 60 plus 60 plus 5x plus 3x equals 360, because now I have another relevant relationship. Now I am using points on a line. Okay, I'm sorry, angles at a point. Excuse me. Angles at a point, which all equal 360. Okay, that's the way I tackled this one. So, like terms are all put together. Okay, and then my 240 is taken away from both sides to leave my 8x there by its lonesome. Of course, I need to get that down to 1x, and I do that by multiplying by the multiplicative inverse, and I get x equals 15. So that is part 1 of our problem solution. But now we need to tend to this, the measurement of angle BAC. And since it is 5x, all I need to do is plug in 15 for that x. I get 75 degrees. Do the same thing with 3x, which is angle BAH, and I get 45 degrees. Okay, so I hope you were successful. And again, the way I know I can prove this, if I do go ahead and add all of these up, and they do indeed equal 360. Okay. All right, so here we go. Next one. 2 lines meet at the common vertex of 2 rays. Okay, in a complete sentence, well, you know the drill again. Finding the value of x, and then the angles DHF and AHD. Okay, so you can find those. We'll go ahead and talk about this when you get back from giving it a try yourself. Okay, good luck. Okay, so I'm going to go ahead and tackle this one by starting right here. I'm going to look here. I know that is 90 degrees right there. Okay, and I also know that if I have 2 perpendicular lines right here and here, because they are perpendicular, and I know that because they've created this 90-degree angle on this right side. Okay, and having done so, that means they've done the same on this side. Therefore, I know this is a 90-degree angle. This is all 90 degrees here. And as that is 90 degrees, I know that we can look at this 2 different ways. We can look at that 42-degree angle there and this other angle here that are side by side. They're adjacent, so they're going to have to equal up to the entire amount of the that larger angle that they make up. Okay, all right, and we just know that is 90 degrees. So therefore, if I go 90 minus 42, I know that this other angle is 48 degrees. Okay, so now I can clean all that up, and now I have this as 48 degrees. Another way I could have done it, of course, is I could have added 90 plus 42, which is 132, and then found out what I need to equal to get to 180, because then that would be angles on a line. So I've used adjacent. I kind of used a combination. I used adjacent angles, but also instead of adjacent, I could have used the complementary. Okay, complementary angles, because you remember complementary angles are two angles that equal up to 90, and that would have been this one and this one. Okay, and that's how I would know that. Complementary angles, right? And then I used angles on a line, another relationship I used. Just good for us to just keep stressing these relationships and why we do what we do. Okay? All right, so there, oopsie daisy, I didn't mean to do all that, but let me go ahead and put that back. 48 degrees, 90 degrees. All right. Now, if we continue, because our task here is to solve for x. Okay, solve for x. Now, what else do you notice on here? And again, you might have done it this way, or you might not have. And if you haven't, just play along with me here. And if you haven't, if you see it, maybe you do, maybe you don't. But again, as these are two lines here that cross intersect right there, we know, therefore, that these are going to be vertical angles right there, these two. Okay, vertical angles. So we've used the vertical angle relationship. Vertical angles relationship. Okay, so therefore I have going to pencil this in as 48 degrees. All right. So now at this point, I don't really need to mess with all of this down here. Okay, I could leave all of these alone. They've served their purpose. They've gotten me to this point. What I can look at now is I can look at these three angles here that are left, 5x, x, and then 48 as angles on a line. Okay, back to the angles on a line relationship, and then figure it out from there. So I'm going to go ahead and just erase all of this, and I'm just hoping that you are paying attention to this yourself. Okay. All right, so it's going to go 5x plus x, okay, and those are coming from here, of course, 5x plus x plus 48 equals 180, okay, 6x, I'll just subtract that 48 away, equals 180 minus 48, what is that, 132, okay, so 6x equals 132, all right, and you know what to do from here. Multiply by the multiplicative inverse, and we're going to get x equals 22. Okay, x equals 22. There we go. We have that. We know x. Let's clean all this up and see if we can do the rest of this. All right. We have our x. We found our x. That is so we know this one here. We know that this is 22 degrees. Okay, 22 degrees. But we also want to find out DHF, which is right here. Oh darn, that's one. Yeah, 22 degrees, of course. All right, DHF is 22 degrees, and also AHD, which is right there. And if we're going to figure out AHD, of course, we're going to plug in our 22 here. So it's going to be 5 times 22. It's going to be 110. So 110 degrees is AHD. Okay. Alrighty. Well, I hope you're having fun doing this. I sure am, because this really isn't all that difficult. You know, it's just a matter of knowing your relevant relationships, and then plugging in numbers and doing some pretty simple equations at this point. So lots of good equation practice. Okay, so this next problem here, this example 4, you can, if you want, to use a protractor. You know, I'm telling you, I'm going to be honest with you, I haven't actually tried a protractor on this paper to see if it's accurate, but you can give it a whirl, okay, or you can could just wait for me to come back and explain it, or maybe think of a different way to do this. But this is a real interesting one, because there's only one number value given, and that's this 30 here, and 30 degrees, but it's also accompanied by another unknown here, another variable, as is this, and there's nothing given here and here. Okay, so a little tricky in that sense because you're going to set up and solve an equation to find the value of x, and then find the measurement of one of the vertical angles. Okay, so I'm going to leave it there. Give you something to muddle. I'd really like you to try this yourself. So go ahead and give it a whirl, and see what you can do, and come on back and watch. I have what I think is a pretty neat strategy. But if you do have a protractor handy, that will help as well, and probably get you to the answer probably more quickly than I will. Okay, so here's what I decided to do. I went and I know this is not very precise, and my lines are a little bit off, but I do know that this is possible. I have these two are vertical angles already, these two here, okay? So I know they are, because they're two intersecting lines, okay? I know they're vertical. Therefore, I know they're equal, okay? And because they're equal, I just went ahead and split this one on this side into 3 pieces, as you can see right there, and each one of those is worth x, okay, is an x, okay, because you need 3 of those to make the entire angle, as we see here. It says 3x, okay, and now I have another set of, I also have those 2 are vertical, okay, I have those are now vertical, and if they are vertical, they are as well equal. Make sure I put that x over there as well, so we have x, 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 and then we have 30, because we're going to just cross out that x there, because now we have our 30 plus x's, actually right here, 30 plus x. We've just kind of divided it to pieces there, okay? So if you see that, you can see how you can set this up. Now you could just set it up as 2x equals 30, and then x equals 15, okay? And where did my 2x come from? Of course, 2x here, 30, okay? 2 of those equal that, and then x equals 15. So that's part 1 of my my solution here, okay? I have that, all right? And then so boom, I go like that, and now I notice also that I have 2 other vertical angles, okay? And those are right here. These 2 across from each other there. Firstly, I did forget to put this whole shoot and match here. These 3 x's are 45. That's 45 degrees right there, and this is also 45 degrees here. And this is why I am adding 45 plus 45, because we know, as angles at a point would tell us, because these are, now we can look at these as angles at a point, okay, all of that is going to equal 360, okay, therefore I will continue as such. So I know that I have the value of these 2 over here already, and that's 45 plus 45, which is that 90, and if I subtract that away from the 360, I'm left with 270. So these 2 vertical angles here now, okay, this one and this one together are going to equal 270, therefore I need to divide that by 2, and each one of those is 135 degrees, okay? And I'm not sure this problem actually asked us to do that, but I decided to do it anyway. Okay, I hope you thought that was fun, and I'd love to see how you did it, if you came up with the right or the same answers as me. All right, here we go again. Same situation here. Set up and solve an equation to find the value of x, and then find the measure of one of the vertical angles. So if you want to, go ahead and maybe use that strategy I used above, or just continue doing what you're doing if you are getting things right. And again, feel free, if you'd like, to use a protractor. Okay, welcome back. And wondering, I went ahead and did the same strategies I did before. You may have used your protractor as you did before, and either one is fine, because we do use protractors in algebra and geometry especially. And here we go. Let's go ahead. What I did is I went ahead again and I split those up into 4 bits, 4 pieces, 4 equal pieces, though they may not look so equal, because I know that there are 4 x's on the one side, and I know they are vertical angles, and because they are vertical angles, I know they are going to be equal. Therefore, it doesn't really matter that I've drawn them perfectly or not. Okay, So what I do know is I can just just trace or just write in my x's, okay, because I have x's, 4 x's on that right side, that right angle, and then on the other side I have 1 x, okay, and 54 degrees, okay. There we go. Again, finding some vertical angles, because I can use those vertical angles because they are equal. All right, and you see what I get? I get 3 x's, okay, is equal to 54, okay. Then x equals 18. All right, and again, just dividing by 3, both sides. All right, so therefore I get 270. The full angles on those of those two full angles there are 72 degrees, and again, it's the full angle here, which is this right here, the whole entire thing in the beginning, which includes the 54 and the x and the 4 x's. Okay. Then, if I want to go a little bit further, I want to find out the measurement of those two other vertical angles, because we are talking again about angles at a point, which equal 360. And just go ahead and do that. I have 216 left over, divided by 2, so I have 108, and if I add up 72 plus 108 plus 108 plus 72, I do indeed get 360. Okay, well, there we are. We are done. We are at less than 40 minutes. All right, so let's go see what we did here. Steps to solving for unknown angles. Now, this is the third lesson here. One more lesson in solving for unknown angles, which is lesson 4, and then we're done with this topic. Okay, and then we're going to move on, and there will be 23 more lessons after that. Really, this is never going to end. Anyway, here we go. Steps to solving for unknown angles. Very, very important, even though I haven't been writing it down all the time. Just identify the angle relationships and go with them. There are several that can help you out. You don't need, if you find one that's just working for you, just work it, man, work it, okay? Then you're going to set up an equation that will yield the unknown value, and sometimes you'll have to, doing this first is great, because then you can fill in other unknown angles, which the problem is not necessarily concerned with, but are going to help you solve it, okay? Then you set up that equation, and you solve the equation for the unknown value, and then, because that's usually x, okay? And then you're going to substitute the answer, determine the angles, and that just means plugging in that value for x to determine the angles. When there's something like 5x, an angle is 5x, you're going to have to plug in x there, and then figure out what that angle measurement is. And then you can check or verify your answer by measuring the angle with a protractor. Now, if you don't have a protractor, you might want to go ahead and get one. Make life easier for you. All right, well, there it is. That's it. And good luck on your problem set, and see you in lesson 4.